Hello, welcome to part 2 of our lesson on structural concrete design. So we will continue from where we stopped in part 1. This is where we continue. We is a summary of hydration that we did. We said that when you mix cement powder, that is concrete containing calcium and aluminum silicate, we mix it with water and aggregate and sometimes admixture together to form the fresh concrete. And so the fresh concrete passes through hydration reaction and the temperature rise followed by cooling plus shrinkage. Then hardened cement paste is formed. The hardened cement paste consists of calcium silicate hydrate, calcium hydroxide, calcium aluminate hydrate, and pour water. So these products create a mechanical bond with the aggregate and steel reinforcement to form a composite material that we call reinforced concrete. So let's look at the use of admixture. Admixture are chemical products added to concrete mix for specific modification and modification to the normal properties of concrete. And they are usually not more than 5% of cement by mass, except on special cases, usually added before batching. Although not an essential component of concrete like cement, aggregate, or water, their inclusion brings considerable physical and economic benefits. It may be organic or inorganic in composition, but their chemical characteristics are usually distinctive from that of mineral additive. Mineral additive has cement replacement. They are added to replace cement, but this admixture are added to modify properties of concrete. Types of admixture, we have accelerating admixture, example calcium chloride. Accelerating admixture, they accelerate early strength development in concrete, so they cause rapid hardening. They are useful in placement of when you're placing concrete in low temperature region. We have places that temperature could be as low as 2 to 4 degrees Celsius, so you can use accelerating admixture to increase the rate of hydration in that place. They are used for manufacture of precast concrete where rapid removal of formwork is desired. So if you're doing precast concrete, you want to remove the formwork fast to increase your rate of production, you might use this accelerating admixture. And for urgent repairs, we are using for urgent repair, you are doing repair work where you want the concrete to harden faster, you might use accelerator. Now note that in high temperature region, accelerators may result in too high rates of heat liberated, and this leads to early thermal cracking. Another one is retarding admixture. These ones are called retarders. Example, sugar, carbohydrate derivative. Now they delay setting and hardening of concrete mix. Like accelerators, they do not alter the composition or identity of product of hydration. They just reduce the rate of hydration reaction, retard setting and hardening of concrete. They are useful in prevention of early thermal cracking when concreting in hot weather or when you are concreting high volume of concrete. You may use it to reduce the hydration reaction, in turn reducing the rate of thermal cracking. Now, when there is a long distance between patching plant and point of placement for a mixed concrete, so if you're mixing concrete and you are transporting it through a concrete mobile mixer and the distance of transportation is high, you might use a retarding admixture to reduce the rate of hydration so that the concrete will not sit before you place it. Another form is called water reducing admixture, example hydroxylated carboxylic acid. Water reducing admixture, it causes reduction of water content in concrete mix, usually about 5 to 10%, and hence useful in achieving good workability at given water cement ratio. So If you want to produce concrete of high strength with a reduced water cement ratio, you can use this water reducing admixture. Now, concrete containing water reducing admixture usually exhibit low segregation because the water cement ratio is low. Another admixture is super plasticizer, frequently used. Now, these are water reducing admixture but that is significantly distinctively higher than those described in under this water reducing admixture. They are called super plasticizers. You can reduce the water cement ratio by up to 30% by including this super plasticizer. Now, inclusion of them results in substantial enhancement in workability at a given water cement ratio, and they are useful in pump concrete and in production of high performance concrete. In short, almost every high performance concrete will use super plasticizer because what actually produces high strength concrete is a use of reduced water cement ratio. Let's look at self-compacting concrete, self-compacting or self-consolidating concrete. Now, this type of concrete expel and trap air without vibration and travel easily around obstacles such as reinforcement to fill all space within the formwork. So self-compacting concrete simply means concrete that you can place without compacting. It will compact itself. So now the following are the criteria for concrete to be classified as self-compacting or self-consolidating. One is ability to expel and trap air without vibration, ability to flow and fill the formwork, ability to pass through closely spaced reinforcement, ability to resist segregation. So those are the criteria for concrete to be classified as self-compacting. Now, self-compacting concrete is achieved by the following means. One, the use of more fine aggregate than usual. Fine aggregate smaller than 600 microns are used. So if you use more fine aggregate, it can help you achieve self-consolidating concrete. Appropriate viscosity achieved by use of controlling agent, like maybe use of water reducing agent or super plasticizer. Now, water cement ratio of about 0.4. The use of super plasticizer, a good aggregate shape and texture. Now, less coarse aggregate than usual, usually 50% by volume of solid. So, those are the ways you can achieve self-compacting concrete. Where do we need self-compacting concrete? Now, it is applicable for intricate pattern of pre-stressed tendon and at poorly accessible area near anchorage. So if you're pouring concrete at a place where you cannot access to vibrate or compact, so you may use self-compacting concrete. They are useful in heavily reinforced members of any shape and with bottleneck, where the reinforcement is much so you cannot easily access to vibrate, you can use it. Now they are used where avoidance of vibration is required, usually for avoiding noise or for health reasons on the part of the operative. Holding vibrator damage nerves and blood vessels and causes hand vibration syndrome. So where you don't need noise, you don't need to use broker vibrator, you can use self-consolidating concrete. They are used to minimize the use of unskilled labor on site. And this thing started in Japan where they don't need much unskilled labor. So you can use self-consolidating concrete. Now let's look at a few composite action. You know that concrete is a composite material, usually aggregate bonded together by hardened cement paste. Reinforced concrete is a composition form construction that is between steel and concrete. Steel reinforcement with a high tensile strength is now steel reinforcement is combined with concrete to form reinforced concrete. Steel reinforcement have a high tensile strength, concrete have a high compressive strength, and both of them have a comparable are compatible. So that is why you can form reinforced concrete. Concrete and reinforcement steel are connected together by mechanical bond between the cement paste and between the concrete and cement. So the bond between cement paste and reinforcement has a huge influence on composite behavior and the ability of reinforced concrete to form. So under normal circumstances, the bond between cement paste and steel reinforcement remain intact. This can be viewed as a form of shear convection, and the two materials exhibit strain compatibility. So these are so we have a few tutorial questions here that you can use to test yourself how you have understood the lesson. So this is where we are going to pause in this part 2 of our lesson. Look out for part 3 on structural steel design. Thank you very much. Please remember to like the page and subscribe to this channel. Thank you.